it will be a function of P, yes? Now, if you're looking at the principal stress criterion, then you're going to use the ultimate strength divided by the safety factor. So that S1 should be less than or equal to that working stress. And then you can get P. How about that? Okay? So here, if you have now your state of stress, you have your sigma theta theta, you have your sigma z z. So we're looking at plane, or we're looking at an inward pressure vessel. So eventually this will be equal to sigma 1 or sigma 2. So if you are using a principal stress criteria, what do you have? Your first principal stress, okay, must be, let me change that. So your ultimate strength must be greater or equal to your first principal, because first principal is higher than principal 2. So your maximum stress is the first principal stress. Now, if you're looking at design, you have a safety factor, so you will have a working stress. So if you're going to include the working stress here, so this one is designing for failure, but if you're designing for safe use, then you have this one to be your ultimate divided by your safety factor n. So this one is your safety factor. I'm sure you have heard of safety factor already. You have mechanical design. Okay? So this is now your working stress. This should be greater or equal to sigma 1. And if this one is, what do we have? 400 megapascal Newton per millimeter squared. This one is 4, and then let's equate it. This one will be, what's your first principal stress? First principal stress, inward pressure vessel. T R all over T. So what is given? This is unknown, so you can solve for T. So what's your thickness? So this one is CR, that is 5 megapascal. R, the diameter is 1 meter divided by 2, so this will be 500 millimeters. And then you have this one to be 100 megapascal. That gives you 25 millimeters. So here, once you have this one, you can check your assumption thin wall pressure vessel if it's okay. D all over T. So if it's 20, you're safe. If it's not, then you have to iterate, check on other criteria. So this one is for principal stress criteria. Try for von Mises, or the distortional stress criteria. example, right? Having a look at this one here. So our initial assumption is that your working stress, ultimate divided by factor of safety, must be greater or equal to your principal. So if you decrease this thickness, what will happen to your principal stress? If you reduce the thickness, what will happen to your first principal stress? Increase. So that this one will be your what? Minimum thickness. So you cannot go lower than 25. You can go higher than 25 because if you go lower than 25, then this one will increase. So if this decreases, that will increase. Yes? So you can increase your thickness to say 50 millimeters and so on, but you cannot reduce the size, otherwise your first principal stress will be greater than your working stress. Or working stress or so-called design stress or whatsoever. If you have a safety factor, it's either you can have a working stress or a design stress. Okay? So solve for the thickness using the 1 Mises.